All right, geometry. The last of our transformations is going to be 9-6, which is a dilation. And a dilation, in my opinion, can be called a shrink or a stretch. A shrink or a stretch. So you have slide, flip, turn, and then shrink or stretch. And the idea behind a dilation is that it's not a rigid motion. It's not a rigid motion. Your figures are not going to be congruent. Dilations create similar figures. You're going to see that they look the same, but the same shape, but one is shrunk and one is stretched, right? Shrink and stretch, shrink, stretch. Okay, so be aware of that, and using our similarity from chapter 7 in today's dilation talk. Okay, so whenever you do a dilation, you need two things. First, you need the center of dilation. That's the point at which you're dilating from. And you need your scale factor, right? If you recall the scale factor. Be aware that this is the function notation, capital D for dilation. The N is your scale factor, and the C is the center of dilation, okay? So a couple things. So if your center of dilation is a point on your figure, then the pre-image and the image will be exactly the same. Okay. For any other point, right, the distance that your image is from the center of rotation divided by your pre-image to your center of rotation is going to be the scale factor. I always think of your scale factor as your new length over your old length. I think that's very, very, very important. Okay. Now, dilations do preserve angle measure, so this is why they're similar. They're similar because your sides are proportional, but your angles are congruent. So in this picture here, again, the side lengths of your figures also follow this scale factor relationship. So to get the length of P prime R prime, you take your scale factor N and you multiply it by the original length PR. That's going to get you the new length. So all your lengths are proportional, and the angles, angle P and angle P prime, will be the same. So in this case, triangle PQR will be similar to triangle P prime, Q prime, R prime. Okay. So it's very important to understand that you can use the scale factor with the distance from your pre-image and your image to the center of dilation. You can also use that scale factor on the sides of the triangle or object itself. Okay. All right. So again, new over old, new over old. Now, the other way that I tried to explain your scale factor was talking about getting bigger, getting smaller. Remember, in similarity, I asked you, does your side you're trying to find look bigger or smaller than the original one? So there are two types of dilations. One's called an enlargement. An enlargement is if your scale factor N, scale factor is greater than 1. You have a reduction if your scale factor is between 0 and 1. So again, it's this idea of if I multiply by a number bigger than 1, I get bigger. I'm enlarging. If I multiply by a positive number less than 1, I am getting smaller. I am reducing. Okay, so keep that in mind as you go through. All right. All right, last but not least, what happens on the coordinate plane? Well, the coordinate plane is very, very easy, very simple, right? As long as you're doing a dilation about the origin, right? Then a dilation of any point with a scale factor of n is just going to be the scale factor times the original x and the scale factor times the original y. So in this case here, P is my original point. When I multiply it by the scale factor of n, I just simply multiply the two coordinates. And again, the distance from O to the pre-image P compared to O to the image P prime, that's your scale factor. So again, your scale factor can be OP prime, the new length, over OP, the pre-image length or the old length. Okay, so keep that in mind. All right, so let's use Desmos geometry to just verify this real fast, and then we'll move on. Okay, so let's take a look at this Desmos geometry. So I have my coordinate plane. Here's my point. Now I called it 4, 2 because I wanted both numbers to be even. And here's my origin that I'm going to dilate around. So I'm going to define a transformation, a dilation. It says choose a center. So my center is the origin. And my scale factor is going to be 2. All right. So what I'm going to do is I'm going to click on point P and I'm going to apply this dilation and see what happens. And there's my point P prime. What are the coordinates of P prime? Well, the coordinates of P prime are now 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 8, comma 4. How can I get that without using Desmos geometry? Well, I simply take my coordinates 4 and 2 and multiply them by the scale factor of 2. Okay. In addition, if you count the slope from the origin to P up to right 4, and then you count the slope from the origin to P prime up 4, right 8, it is doubled. Okay. And again, you can use the slope to find distance, so the distance is doubled. All right, now let's do that was an enlargement. Our point got farther away. Let's do a reduction now. Okay, so let's define another dilation, origin, and now let's do 1/2. Let's do 0.5. There we go. I didn't like 1/2, sorry. Okay, so we're going to click on point P. We're going to apply this, and boom, look, it got closer to the origin. Now let's check out its coordinates. So P prime is now the point 2, 1. How can I do this without using Desmos geometry? Well, you just take half of your coordinates. Half of 4 is 2, half of 2 is 1, and boom. And that's a reduction. Okay? So very simple on the coordinate plane. Just simply multiply it by the scale factor. All right, let's take a look at an example or two through Delta Math. Okay, let's look here. So it says, what is the image of -3, -9 after a dilation by a scale factor of 1/3 centered at the origin? So simply what you're going to do is you're going to take each of your coordinates and multiply by the scale factor. -3 times 1/3, -9 times 1/3. And that's going to be -1 and -3. And that's it. Very simple with dilations. Bada bing, bada boom. Okay, so this is the only dilations video. You're going to have another assignment at the end of the week that's going to now encompass all of the transformations, the 3 rigid motions, translations, reflections, rotations, and this non-rigid motion of dilation. And again, it's going to get into congruence versus similarity. So it's a really good recap of the week. So make sure you're really focusing on that for Thursday leading up to the quiz Friday. All right, thanks for watching.